A group of 6 boys and 5 girls are to be photographed together. The girls are to sit on the 5 chairs placed in a row, and the boys are to stand in line behind them. Find the number of different arrangements for the photo taking. So you'll notice that the way the girls sit and the way the boys sit are actually independent. There's no intermixing here. So using the multiplication principle, we look at the number of the ways the girls can order themselves. That's 5 factorial. Look at the number of ways the boys can order themselves. That's 6 factorial. Because they're independent, I can just multiply those two numbers together. It's a big number. It's 86,400 ways. So if you like, as a way of explanation, this is 5 factorial ways for girls to sit. This is 6 factorial ways for boys to sit. So, for a second photograph, the boys and girls are to be arranged with 3 boys and 3 girls standing, while 3 boys and 2 girls are seated in the chairs in front of them. And in each row, the boys and the girls are to occupy alternate places. Find the number of different possible arrangements. Okay, so what do we have here? This one's quite complicated, but largely because they've given us so many conditions here. We have 6 places at the back. 1, 2, 3, 4, 5, 6. We've got 5 places in the front. 1, 2, 3, 4, 5. How many ways can we do this? Well, firstly, we need to put 3 boys, boy 1, boy 2, boy 3, say, into the back row. How many ways can I choose these 3 boys to go into the back row? Well, that is, from the 6 boys I have, I choose 3 of them to put into the back row. Then I also need 3 girls to go into the back row. So how many ways can I do that? Well, that's from the 5 girls, choose 3 of them to go into the back row. And then you'll notice that I had boy, girl, boy, girl, boy, girl, right? Alternating. Well, okay, no, just before that, you notice then I now have 3 boys left, 2 girls left, so the only way I can have boy and girl alternating in the front row is to have it like this, with the boys on either ends and the girls in the middle and 1 boy smack bang in the middle. So I can't change the ordering of this front row, right? It has to be boy, girl, boy, girl, boy. So at the back, what do I have? Well, now I've got boy, girl, boy, girl, boy, girl. I could also have girl, boy, girl, boy, girl, boy. So I've got 2 ways of choosing the way the boys and the girls go. Then, in the front row, what do I have? Well, I've got 3 factorial ways of arranging the boys, 2 factorial ways of arranging the girls. What about in the back row? I've got 3 factorial ways of arranging the boys, 3 factorial ways of arranging the girls. So what does that give me? That gives me a very, very big number, but you guys can work that out now. It is 172,800 ways.